Hi friends, welcome to GTS classes. Today fluid statics session 4 part 4. In last session fluid statics part 3 I explained Archimedes principle and others. Today I'll explain our apparent weight and hydraulic lift and U-tube. Those I'll explain. Now apparent weight of a body submerged in the liquid. If you didn't saw those old videos, the links are in the description. You can watch those. So we'll enter into our topic. Apparent weight of a body submerged in a liquid. Now, if we take, see, this is a vessel and this is a spring balance. Okay, this has a water up to here and it is hanging a mass, it is carrying a mass M, capital M. Okay, capital M. This is spring balance. So now down, mg is acting downwards and tension, upward tension is acting. So now T is acting upwards. If we take reading in air, see, if we take reading in air, then mg, this is mg, see, this is m and m is acting downward, mg is acting downwards, tension upwards. See, this is reading in air, okay. So T is equals to mg. T by G is equals to m. So no reading will be T is equals to mg. So no extra force, no external force. But here, see, but in this case, buoyant force is also acting upwards. FB. Buoyant force is also acting upwards. So here T plus FB is equals to mg. So we'll transport this FB this side and T is equals to mg minus FB. We know force of buoyancy formula. FB is equals to volume into volume of cross section area, that one, into rho into G, density of the liquid into G. So we'll take G common. Okay, I'll write the formula first. See, mg minus rho L into volume into density into gravity. Here we'll take G common. So m minus v rho. Here T by G is the reading. Tension by gravity is the reading of the spring balance. You may learn it. So m minus Vp from this equation. M minus V rho. Reading is T by G is equals to m minus V rho. So T by G is equals to m minus volume into density. Volume of the body into density. See, this body is of density rho of the body, and this liquid is of density rho. You know it. So volume of the body is equals to mass of the body by density of the body. So T by G is equals to m minus see, we'll substitute this value in place of this. So m minus m by rho of the body into rho of the liquid. So T by G is equals to m common 1 minus rho of the liquid by rho of the body. See, I write here the formula. T by G, the reading is equals to, T by G is equals to, we will take M common, and 1 minus rho of the liquid by rho of the body, density of the body. This is the formula of apparent weight of a body submerged in a liquid. Now, Pascal's law. Pascal's law, if we take a closed container, then if an external force is applied on any side of that, if an external force is applied, then the change in the pressure takes place in all parts of the fluid, transmitted undiminished in all parts of the fluid. See, I will explain. This is a container. I will say one example. If we take toothpaste, in that we will, if we apply pressure, if we apply force in one end, then from other end the toothpaste will come. That is because of Pascal's law. So now I will explain. If we take in this container, this is a vessel containing liquid, a liquid of density rho something. This is one end, and this cross sectional area of this one is A1. So an external force F1 is applied here. So the pressure P1 is equals to F1 by A1. So an external force is applied from here. Then it will push the water now. So the pressure, it will push the water. Force will push the liquid liquid. So the pressure will act here. That pressure will push these. That pressure will push these pistons. These are the pistons. Those will move. Then the pistons will move, and the liquid will move. So to prevent the movement of pistons and liquid, all the forces in all sides should be equal. F2, see F3 here, F3, here F2, and here F4. Then P2 is equals to F2 by A2, and P3 is equals to F3 by A3, and P4 is equals to F4 by A4. See, F4 by A4. To prevent the movement of pistons and the liquid, then pressure at all the pistons should be equal. So P1 is equals to P2 is equals to P3 is equals to P4. So F1 by A1 is equals to F2 by A2 is equals to F3 by A3 is equals to F4 by A4. This is Pascal's law. So the movement of pistons is only the Pascal's law. See, the pressure, the force is applied in only this direction. Starting at initially the force is applied at only this point. At this point, then the pressure at here, because of the force applied here, the pressure is acting on every piston, on all the parts of this fluid. So that is Pascal's law. And if the piston should be at equal at rest, and to prevent the motion of the pistons and the liquid, the pressure at the four pistons should be equal. So F1 is equals to F2 is equals to F3, that only. F1 by A1, P1, P2, P3, P4 should be equal. Pascal's law means a pressure is applied in an enclosed vessel. The pressure is applied. If the pressure is applied at one point, then if a external force is applied at one point, then the pressure will act in all parts of the fluid. Now, U-tube, pressure distribution in U-shaped tube. See, we will take a U-shaped tube. This is a U-shaped tube, and this is filled of some liquid of density rho. See, this is filled with some liquid of density rho. From upward, PATM is acting both sides. If it is acting one side also, it will be distributed in all parts. I said in Pascal's law. See, we will take a point A, B, and another point M, N. These both are of same level. These both are at same level. See, these both A and B. So height from height is H1 from the top of the rim, and M, for point M, height is H2. So now PA is equals to PB because they both are at same level. Now PATM, PA is equals to PATM plus H rho G. See, this liquid is of density rho, H rho G, and PA is equals to PB is equals to H rho G, and PM is equals to PN is equals to PATM plus H2 rho G. This is H1 rho G and H2 rho G. Now if we add another liquid of more density, see here, see, if we add another liquid, see, another liquid up to B, it will come up to B. See, then it is of density rho dash. We will take rho dash. Then PA and PB, then also PA and PB will be equal. So PB, now PB is equals to PATM plus, this is a height, we will take this height X, okay, and this height Y. So PATM is equals to X rho G, X rho dash G, and PA is equals to PATM plus Y rho G. So PA is equals to PB here also. Now we say I write here PATM plus plus X rho dash G is equals to PATM plus Y rho G. So PATM and PATM will get cancelled because if it will come here, PATM minus PATM both will become 0, and X rho dash G is equals to Y rho G. G and G will get cancelled. So X rho is equals to Y rho. X rho dash is equals to Y rho. This statement represents us that in U-shaped tube, the height into density is constant. Height into density is constant. That says in U-shaped tube. That is the distribution in U-shaped tube. My next video will be on accelerating fluids, pressure distribution in curve-shaped vessel, and another one hydraulic lift. Those three will be in my next video. If you like my explanation, kindly like, share and subscribe to my channel.